Welcome to most important MCQ series of electronics device and circuit. This is solution part of quiz 2 and the topic is pn-junction diode. Okay, question number 1 is the AC resistance of a forward biased pn-junction diode operating at a bias voltage V and carrying current I. Okay, so यदि हम characteristics की बात करें, characteristic of p-n junction diode, so the x-axis which is indicated by voltage axis and the y-axis which is current axis. Okay, so this is the characteristics. Okay, so forward bias characteristic, this is the forward bias characteristics. Okay, so there are two current. Okay, one is forward current. Okay, one is static current. ठीक है, किसी पर्टिकुलर वोल्टेज पर करंट का वैल्यू उसको आप सपोज दिस इज आई डैश एंड दिस इज वी डैश. सो the static resistance R of S which is equal to V dash divided by I dash. But in the case of dynamic resistance or which is forward resistance of the diode, so which is the change in voltage to the change in current. Okay, so this change is del V. Okay, and this change is del V and this change is del I. So the ratio of del V and del I, which is resistance of PN junction diode or forward bias resistance of PN junction diode. So the option number D is the correct option. Okay, now the question number 2. The depletion layer across a p positive n junctions lie. Okay, so p positive, that means highly doped semiconductor. P positive, that means highly doped. Okay, ठीक है. अब जब हम बात करें पी एन जंक्शन डायोड की, तो एक पी टाइप सेमीकंडक्टर है, ठीक है, इस तरीके से, और एक एन. सो दिस इज पी टाइप सेमीकंडक्टर एंड दिस इज एन टाइप सेमीकंडक्टर एंड दिस इज द जंक्शन. पी पॉजिटिव का मतलब क्या होगा, आपने हाईली डोप्ड सेमीकंडक्टर यूज किया है. ठीक है, अब यहाँ पर क्या होगा, हाईली डोप्ड सेमीकंडक्टर की मैं बात करूं, ठीक है, तो आपने पी पॉजिटिव बोला है, मतलब पी पॉजिटिव. अब यदि पी और एन में सेम डोपिंग होता, फॉर एग्जांपल एन द कंसंट्रेशन ऑफ एक्सेप्टर एटम व्हिच इज इक्वल टू कंसंट्रेशन ऑफ डोनर एटम. ठीक है, तो इसका मतलब जो यहाँ पर डिप्लीशन बिट फॉर्म होता वो इक्वल होता. ठीक है, लेकिन जैसे ही आपने एक्सेप्टर कंसंट्रेशन इंक्रीज कर दिया, तो द बिट व्हिच इज इनवर्सली प्रोपोर्शनल टू द डोपिंग कंसंट्रेशन. ओके, और यदि आपने डोपिंग इंक्रीज किया है तो उस जंक्शन में बिट्स हो जाएगा डिक्रीज. इसका मतलब पी साइड बिट्स में क्या होगा, डिक्रीमेंट आ जाएगा. ठीक है, इस तरीके से शिफ्ट हो जाएगा. ठीक है, तो इसीलिए हम बोल सकते हैं कि द डिप्लीशन लेयर विच इज मोस्टली इन द एन रीजन. ओके, दैट्स व्हाई द आंसर ऑफ दिस क्वेश्चन इज ऑप्शन नंबर बी. ओके, नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 3. द डिफ्यूजन कैपेसिटेंस, okay, of a p-n junction diode. So first of all, diffusion capacitance, it is in forward bias. ये diffusion capacitance जो होगा वो आपके, जब आपका डायोड p-n junction डायोड जब आपका फॉरवर्ड बायस में होगा, ठीक है, तब आपका डिफ्यूजन कैपेसिटेंस फॉर्म होता है. लेकिन जब आप रिवर्स बायस की बात करें तो रिवर्स बायस में ट्रांजिशन डायोड, ट्रांजिशन कैपेसिटेंस कंसीडर किया जाता है. ठीक है, तो अब यहाँ पर जो आपका फॉरवर्ड बायसिंग में हम बोलते हैं कि जो आपका चार्ज का ट्रांसमिशन हुआ है which is equal to capacitance into V and this capacitance is called diffusion capacitance. Okay, so further we can write this Q which is equal to I into T, or we can write I into tau, and this is equal to C into V, and so that we can write the diffusion capacitance, that is CD, which is equal to tau into dV by di. I'm so sorry, tau into di by dV. Okay, and what is I? I is a diode forward current because this capacitance which is in forward bias. Okay, so forward diode current I, which is equal to I naught into e to the power Vd, that is voltage across the diode, divided by eta Vt -1. Okay, so we can differentiate this. So di by dv, which is equal to I naught into, so this is e to the power, so e to the power x differentiation, which is also e to the power x, so vd divided by eta vt. Okay, and okay, and into differentiation of bd. Okay, bd, this is differentiation with respect to vd, so differentiation is eta into vt. Okay, so this diffusion capacitance, which depends on the forward voltage of the diode. Okay, so we can say it increases exponentially with forward bias voltage. You can write further this cd equal to tau into di by dv. So di by dv की जगह हम put कर सकते हैं I naught into e to the power vd divided by eta vt and divided by eta vt. ओके, सो इसका मतलब होगा कि जो आपका फॉरवर्ड बायस वोल्टेज है दैट इज vd, उस पर एक्सपोनेंशियली इंक्रीमेंट होगा विद रिस्पेक्ट टू फॉरवर्ड बायस वोल्टेज. ओके, सो द डिफ्यूजन कैपेसिटेंस ऑफ द पीएन जंक्शन डायोड इंक्रीजेस एक्सपोनेंशियली with forward bias voltage. Okay, so the correct answer for this question is A. Okay, next, the reverse current of a silicon diode is, reverse current is, option is highly bias voltage sensitive. Okay, then highly temperature sensitive. Okay, so both bias voltage and temperature sensitive, and independent of bias voltage and temperature sensor. Okay, so this reverse current, okay, this reverse current of the PN junction diode, which is actually independent. Okay, so independent of bias voltage, so this is independent of bias voltage, and this is highly sensitive to the temperature. Okay, so we can write this IR, which is actually equal to or we can say, suppose we have saturation current or reverse saturation current IS for temperature T2 equal to IS of T1. Okay, and it is into 2 to the power T2 minus T1 divided by 10. Okay, so यदि आप 10 डिग्री सेल्सियस टेम्परेचर में इंक्रीमेंट होता है तो आपका जो रिवर्स करंट होगा वो डबल हो जाएगा, 2 into IS. This is very important point. So that's why this reverse current of the silicon diode, which is highly sensitive, highly temperature sensitive. Okay, so the option B is the right answer. Okay, now question number 5. The depletion region in a semiconductor PN junction diode has, okay, so we have PN junction diode like this, PN junction diode. Okay, this is P side and this is the junction and this is the N side. Okay, so जो N टाइप सेमीकंडक्टर होगा उसमें जो मेजॉरिटी चार्ज कैरियर्स होंगे इलेक्ट्रॉन्स होंगे, ठीक है, और जो माइनॉरिटी चार्ज कैरियर्स होंगे वो होल्स होंगे. और फॉर P टाइप सेमीकंडक्टर मेजॉरिटी चार्ज कैरियर्स आर होल्स, ओके, एंड माइनॉरिटी चार्ज कैरियर्स आर इलेक्ट्रॉन्स. ठीक है, और ड्यू टू डिफ्यूजन फेनोमेना इलेक्ट्रॉन्स जो होंगे N टाइप सेमीकंडक्टर से P की तरफ मूव होना स्टार्ट करेंगे, और जैसे ही एक इलेक्ट्रॉन का यहाँ पर लॉस होगा तो एक पॉजिटिव चार्ज जो है डिप्लीशन रीजन के पास में आ जाएगा. ठीक है, लाइक दिस, इस तरीके से आप समझ सकते हैं. और गेनिंग ऑफ इलेक्ट्रॉन will produce negative sign like this, so there will be a depletion layer like this. Okay, so we can say there will be a positive and negative ions on either side, so option B, which is the right option. Okay, next, when a positive DC voltage is applied to the N type semiconductor related to P side, a diode is said to be a given. Okay, so this is the PN junction diode, symbol of PN junction diode. Okay, we applied the positive terminal of the battery connected to the N side, okay, like this, and the negative terminal of the battery connected to the P side like this. Okay, the N side related to P side. Okay, so the diode is, so this is the forward bias, reverse bias case. This is the reverse bias case. Okay, so option B is the right option. Question number 7. In an open circuited PN junction, diode space charge density at the junction. Okay, so we have a diode like this. Okay, this is the junction. There is a negative charge. Okay, and there is positive charge. Okay, so the charge density would depend on the concentration or donor concentration ND and the acceptor concentration Na. Okay, so in this case the charge density which depend on the ND. Okay, so Q into ND, and because of negative sign there will be a negative of QND, and this side positive, that is Q into Na. Okay, so it will be like this. Suppose this is the junction, so junction के across इस तरीके से minus QND and plus QND, QNA for sorry. So, and this is the width of the depletion layer. This is the width of the depletion layer. Okay, so at this junction, the charge density will be 0. Okay, it will be 0 because suppose N equal to Na equal to ND. Okay, so this amount and this amount is equal. That's why the total charge density or resultant charge density will be 0. Okay, so option B is the right answer. Next, question number 8. Question is, the doping concentration on the N side of a PN junction diode is enhanced. Which of the following will get affected? Okay, so situation is like this. We have P-type semiconductor, N-type semiconductor, and this is the junction. Okay, and there is a depletion width on the P side, and there is a depletion width on the N side. Okay, so there is a positive sign and there is a negative charge. Okay, so the question is, the doping concentration on the N side is enhanced. That means the doping concentration, or we can say on the N side, that is the donor concentration is increases. Okay, in that case, the depletion width will affect. Why? Because the width of depletion region inversely proportional to the doping. Okay, if doping will increase, okay, in that case the width of the depletion region decrease. Okay, that's why E will be the right answer. Okay, now the question number 9. What is the typical value for the ratio of current in a PN junction diode in the forward bias and that in the reverse bias? Okay, so the idea is, in the forward bias, the current ID, the unit of current ID, which is microampere. Okay, and in the case of reverse bias, the unit of diode current, which is nanoampere. Okay, so easily we can find the typical value of this ratio, that is forward divided by reverse. So microampere divided by nanoampere, it will be 1000. Okay, so the correct answer for this question, which is option number D. Okay, now question number 10. Question number 10 क्या कह रहा है? There is a two statement. Consider the following statement for N PN junction diode. Okay, so statement number 1, it is an active component. ये बिल्कुल सही है, एक active component है. Okay, resistor, capacitor and diode are a passive component, where PN junction diode which is active component. Okay, so statement A which is correct. Okay, now for statement number 2, depletion layer width decreases with forward biasing. Yes, this is also the correct statement, because when the forward bias increased, okay, the junction voltage increases. In that case, the width of the depletion region which is decreases. Okay, फॉरवर्ड बायस में आप जैसे जैसे बिट वोल्टेज इंक्रीज करेंगे, आपका डिप्लीजन बिट डिक्रीज होगा. नाउ स्टेटमेंट नंबर 3, इन अ रिवर्स बायसिंग केस saturation current increases with increasing temperature. Okay, so we know that this is of T2 which is equal to is of T1 into 2 to the power T2 minus T1 divided by 10. ओके, जब टेम्परेचर 10 डिग्री से इंक्रीज होगा तो आपका जो रिवर्स करंट है वो डबल हो जाएगा. ओके, दैट्स व्हाई थर्ड स्टेटमेंट इज आल्सो करेक्ट. ओके, सो द करेक्ट आंसर which is A, option number A. Okay, now question number 11. Question number 11 is a potential barrier of 0.50 volt exists across a PN junction. Okay, good. So the idea is like this. There is a PN junction diode. Okay, and there is a potential barrier that is V equal to 0.50 volt. Okay, and the width of the depletion region, that means here this is the width, okay, W, and this W equal to 5 into 10 to the power minus 7 meter. Okay, so what is the intensity of the electric field? Okay, so we can calculate electric field with the help of V divided by D, distance. So here distance will consider as a width of the बहुत तेजी आ रही है. The distance will be W. Okay, so V which is 0.5 and the D, that is distance, which is 5 into 10 to the power minus 7. Okay, so this is 1 into 10 to the power minus 6 volt per meter. Okay, so the option A which is the right answer. Okay, now question number 12. Consider an abrupt PN junction. Let VBI be the voltage potential. Okay, no problem, of this junction, and VBR be the applied reverse bias. Okay, if the junction capacitance CJ is 1 picofarad for VBI plus VR equal to 1. Okay, so the given part is there is a VBI plus VR, okay, and CJ. So in the case of VBI plus VR equal to 1 volt, the CJ is 1 picofarad. Okay, now there is a VBI plus VR is 4 volt. Okay, we need to calculate CJ. Okay, so the relation between CJ and VBR, which is inverse, so this is square root of VBI plus VR. Okay, so we can say the CJ which is 1, so in that case, okay, and for the second case CJ, okay, and this is equal to square root of VBI. Okay, so this is 4 divided by 1, so this 1 upon CJ which is equal to 2, and CJ is 1 by 2. Okay, 1 by 2, that is 0.5 picofarad. What is 1? What is the unit of this one? Which is picofarad. So you can write CJ equal to 0.5 picofarad. Okay, so correct answer is D. Okay, now the question number 13, very important question. Question number 13. In the circuit shown below, the ideality factor eta of the diode is unity. Okay, so eta is given, eta equal to 1, and the voltage drop across it 0.7, that is VTH. Actually this is VTH, which is equal to 0.7. okay, what is the dynamic resistance? Dynamic resistance, that is forward resistance. okay, it is also called forward resistance of the diode at room temperature. So at room temperature, that means the VT, okay, the VT, which is equal to 26 millivolt. okay, this is the concept behind VT. okay, so we require dynamic resistance. okay, so we have dynamic resistance, that is we have current. okay, we have current I, which is equal to Is into e to the power Vd divided by eta Vt. okay, अब डायनामिक रेजिस्टेंस की हम बात करें तो ये वोल्टेज डिवाइडेड बाय करंट होगा. तो सबसे पहले मैं एक डायनामिक रेजिस्टेंस की बात कर रहा हूँ. तो मैं यहाँ पर डिफरेंशिएशन फाइंड आउट कर लूँ, दैट इज डी आई बाय डी वी. ओके, डी आई बाय डी वी. ओके, and this is equal to differentiation with respect to Vt. okay, so this is equal to Is into e to the power Vd. so e to the differentiation, which is same, e to the power Vd divided by eta Vt, and differentiation of Vd, which is 1 upon eta Vt. so that's why this is 1 upon eta Vt, that is Is into e to the power Vd divided by eta Vt divided by eta Vt. okay, so the dynamic resistance. okay, so further we can write this is diode current Id, no problem. This is the same, this is Id. okay, this is Id. so that's why we can write this part, which is equal to Id, and Id divided by eta Vt. okay, so this is transconductance G. okay, so inverse of transconduction with the dynamic resistance, that is 1 upon G. okay, so this is eta Vt divided by Id. okay, now what is Id? So we can calculate from here this diode current Id. okay, and the diode voltage, which is 0.7. okay, so clearly you can calculate Id. The Id equal to this 1.7 minus 0.7, that is 1 divided by 1k. so the Id is 1 milliampere. okay, so we can calculate R, that is dynamic resistance, which is eta. so eta is given, that is 1. Vt is for at room temperature, which is 26 millivolt. okay, and divided by Id. so Id is 1 milliampere. okay, so this milliampere part will be cancelled out. okay, so the resistance will be voltage upon A, that is resistance, and it is 26 ohm. and we can choose approximate value of this resistance, that is 25 ohm. so correct answer for this question is option number B. okay, now next question number 14. okay, so the question number 14 is, a sample of n-type semiconductor has electron density of 6.25 into 10 to the power 18 per centimeter cube. okay, so n-type semiconductor electron density given, that is donor concentration is given. so the Nd equal to 6.25 into 10 to the power 18 per centimeter cube. okay, no problem with this. okay, if the intrinsic concentration of carrier in the sample is 2.5 into 10 to the power 13 per centimeter cube, that is Ni is also given. Ni equal to 2.5 into 10 to the power 13 per centimeter cube. okay, and there is a room temperature. We need to calculate whole density. okay, so we can use mass action law, that is N into P, which is equal to Ni square. okay, so we need to calculate this P. okay, so we can write this P equal to Ni square divided by Nd. okay, so Ni square, that is 2.5 into 10 to the power 13 square divided by ND. So what is ND? ND is 6.25 into 10 to the power 18. So this is 2.5 square, that is 6.25 into 10 to the power 26 divided by 6.25 into 10 to the power 18. So this is approximately equal to 10 to the power 18. I'm so sorry, 10 to the power 8. 26 minus 18, that is 8. Okay, so 10 to the power 8 per centimeter cube, that is option number B, which is the correct option. Okay, very important question. Okay, now question number 15. Okay, the question number 15 is the IV characteristics of diode is given. Okay, this is characteristics of diode. Okay, what is the करंट इन द सर्किट. अब इस क्वेश्चन को सॉल्व करने के पहले आपको डायोड का इक्विवेलेंट सर्किट बनाना पड़ेगा. ओके, सो दैट we required internal resistance for the diode. Okay, so we can calculate the internal resistance of the diode with the help of this characteristics. The given part is I equal to V minus 0.7 divided by 500. Okay, so यहाँ से मैं calculate कर सकता हूँ. So which is, we know that what is RD? Dynamic resistance equal to del V by del I. We know that. Okay, so and this is equal to 500 I equal to V minus 0.7. Okay, so differentiate this. So this is, so differentiate this. So we have, okay, so V equal to 500 I plus 0.7. so now we can calculate dV by di, and this is equal to 500. Okay, this is RD, that is dynamic resistance. So here we can replace this diode like this, the diode resistance, that is RD, which is equal to 500. Okay, and the battery, because there is some potential drop 0.7, so the battery will be like this. Okay, so this is 0.7. okay, we can use like this. Okay, so now we require the current in the circuit, that is current I, for example I. So using mesh equation, this is equal to minus 10 plus 1k into I. Okay, then RD, so 500 into I plus 0.7, and this is equal to 0. So 1.5k into I equal to 9.3, and I equal to, okay, so I equal to 9.3 divided by 1.5k. okay, so this will be in the milliampere, and it will nearly 6.2 milliampere. Okay, so option D, which is the correct option. Okay, next question is, a silicon PN junction at temperature of 20 degrees Celsius has a reverse saturation current. Okay, so IS, okay, and the temperature. Okay, so IS equal to 10 picoampere at temperature 20 degrees Celsius. Okay, the reverse saturation current at 40 degrees Celsius. We required IS for 40 degree Celsius. So we know that the temperature dependency of saturation current. So IS2 T2 equal to IS of T1 into 2 to the power T2 minus T1 divided by 10. Okay, so IS of 1 which is given, IS of 1 which is 10 picoampere. Okay, into 2 to the power T2, that is 40, minus T1, that is 20 divided by 10. So it will, this is 40 minus 20, that is 20 divided by 10. So it will be 4 into 10 picoampere, that is 40 picoampere. That is option number B, which is the right answer. Okay, Fine. Okay, now the next question is for a circuit in the figure given below, the voltage VO is, okay, so we require this voltage VO. Okay, that means we require the potential at this particular point. Okay, so for the conduction of this diode we require this voltage. Okay, so let this diode, which is ideal because there is no knowledge about the type of PN junction diode. So हम यहाँ पर इस तरीके से इसको कर सकते हैं कि this potential is VO, so we can calculate, suppose for example this is V. Okay, so V or we can say this is V1. Okay, this is V1, so V1 minus 4 divided by 2 plus V1 plus 2, because this is negative sign, so we require positive here. So V1 plus 2 divided by 2, and this is equal to 0. So this V1 minus 4 to cancel out, so V1 minus 4 plus V1 plus 2, this is equal to 0. So 2 V1 equal to 2, so V1 equal to okay, so V1 equal to 1. Okay, so at this particular terminal V1 is 1, and in that case this diode will be in the forward bias. Okay, so we can choose the answer of this question, which is option number B. Okay, so B is the correct option. Okay, next question number 18. In the diode equation, the voltage equivalent of temperature, so we know that this diode equation ID equal to IS, that is saturation current, into e to the power Vt divided by eta Vt. Okay, so this Vt, which is actually thermal equivalent or voltage equivalent of temperature, that is Vt, and this Vt equal to T divided by 11,600. Okay, so the V is the right answer for this question. Okay, now question number 19. The arrow direction in the diode symbol indicate. Okay, so this is the diode symbol, and here there is a direction of, okay, so this is from N to P, or I'm sorry, this is from P to N. Okay, this is P and this is N. So the direction of the electron flow, no, क्योंकि जो इलेक्ट्रॉन का जो डायरेक्शन होगा वो N से P की तरफ होगा. Okay, direction of hole flow, okay, it is possible. Okay, so the whole direction of hole which is from P to N. Okay, so option B, which is the correct option for this question. Okay, now question number 20. When the diode is forward bias, it is equivalent to, okay, जब भी आपका डायोड फॉरवर्ड बायस में होगा, ठीक है, तो हम इसको ऑन स्विच की तरह बोल सकते हैं कि वो एक ऑन स्विच है. ओके, ऑन बोल सकते हैं, दैट इज ऑप्शन नंबर बी. ओके, थैंक यू.